Now let us come to the relation between the EMF, terminal voltage or the terminal potential difference, and the internal resistance. So we will come to the relation between the EMF, number one. Second one is the terminal voltage or the terminal potential difference, and third one is the internal resistance. So let us find the relation between the EVR. Okay, EMF, terminal voltage or terminal potential difference, and the internal resistance. Now for this, now let us follow the same condition which I have discussed before. Open circuit and the closed circuit. Okay, just follow the diagram of a cell. Just now I have explained that the two electrode which is immersed in a electrolyte, and the two electrodes are not connected with the external circuit. It is an open circuit, and other one is a closed circuit in which the two terminal of the electrode are connected with the external circuit. So following that two conditions here. So number one, the first one is there, this point. In an open circuit, when the circuit is open, the current is not drawn. There is no current. So I can write here I equals to 0. So this is for open circuit. Okay, open circuit. Okay, where the circuit is open, no current is drawn from the cell, and therefore I equals to 0. I can write I equals to 0. But what will happen, even though there is no potential difference between the electrode, there is no current flowing to the electrode, but the potential difference is maintained between the electrode. In an open circuit, no current is drawn, but the EMF will be developed there. Okay, that is electromotive force. So therefore I can write V equals to E, because electromotive force is also the potential difference. Okay, and V is equals to E. So this I equals to 0 and V equals to E can be written when the circuit is open. So this is the first condition here. And the second condition is there again. We know that from Ohm's law, V equals to IR or IR equals to V from the second law. Now here, in this case, the circuit is closed now. Okay, circuit will be closed circuit. This is closed, CIRCUIT. So this is for closed circuit. So in a closed circuit, what I have written here, now when the circuit is closed, now the current will flow. And according to Ohm's law, the current flowing through the external circuit is given by I equals to V upon R. That is from Ohm's law. Okay, so from Ohm's law we know that IR equals to V equals to IR, and IR equals to V, I equals to V upon R. So taking this condition here. Okay, so the lower portion is when the circuit is closed. Now first one is when the circuit is open. When the circuit is open, the current is not drawn, so I equals to 0. Even though there is no flow of current, but the electrode will maintain the potential difference, maximum potential difference, which we call it as a EMF. Okay, so I can write here V equals to E. Why V equals to E means, but the potential difference is equivalent or equal to EMF, because EMF is also potential difference and V is also the potential difference. So V equals to E. This is for the open circuit. Now when the circuit is closed, I can write from Ohm's law V equals to IR, IR equals to V, or I equals to V upon R. So I can write here I equals to V upon R. Now substitute. Instead of V, I equals to, what is the value of V given here? E. I can write it here E. Then after that, R means the resistance, but the resistance is offered by the cell also as well as by the external circuit also. So I can write, instead of writing single R, I am writing R plus small letter R. That means this R plus small letter R is the total equivalent resistance. Equivalent resistance means the total resistance of the total resistance offered by the electrolyte of the cell, which is the internal resistance, and also the resistance offered by the electrode, okay, in external circuit. So I equals to E upon R plus R. Now after that, cross multiply here, E equals to IR plus IR. Then we know that V equals to IR. Make this as equation 1. V equals to IR. Make this as equation 2. Then E equals to, substitute the value of IR as V. Since IR is equivalent to V, so I can write here V. So E equals to V plus IR. Then bring this V on the left hand side. So minus V equals to minus, take this on the right hand side, minus E plus IR. So minus V equals to, you take minus as common here, minus inside the bracket E minus minus into plus will become minus IR, minus minus cancels here, so that will become V equals to E minus IR. So this shows that the terminal potential difference is less than EMF. Okay, terminal potential difference means the terminal voltage is less than EMF. Okay, because why the terminal voltage less than EMF is because the internal resistance is offered by the electrolyte. Okay, because EMF is the potential difference when the circuit is open and no current is drawn. So from that condition, taking that factors, that condition, I can write it here, terminal potential difference is less than EMF. So this equation shows that terminal potential difference is less than EMF. Then what you do is that now bring this side, bring this plus E, okay, positive E towards the left hand side, that will become minus E plus V equals to minus IR. Then minus, you take it common here, E minus plus will become minus, V equals to minus IR. So minus minus cancels here, E minus V equals to IR. So this equation gives drop in potential. Okay, so this is the formula, voltage drop or drop in potential. This is the equation to find the potential drop or the drop in voltage. Now the next one is, let us find the internal resistance. How to calculate internal resistance? Again, following the same equation here, I equals to E upon R plus R. Okay, then from equation 2, in equation 2 it is given as V equals to IR. Now substitute the value of I here. Okay, so what we do is that V equals to IR means V equals to, what is the value of I here? E divided by R plus R. E divided by I plus R, you substitute here into R, multiplied here, then V cross multiplied V into R plus R, then ER. Then after what you do, R plus R equals to ER, this V will come as the denominator divided by V. Then R equals to ER divided by V, take this plus R on the right hand side, that will become minus R. Then R equals to, since the R is common here, you can take calculator R common, that is the external resistance. So E upon V minus 1, already R we have taken common here. So this formula is used to find the internal resistance of the cell. So this is the derivations of the formula, as well as the relation between the EMF, electromotive force, terminal voltage, and the internal resistance. Okay, so please follow it properly and understand it. Thank you.